Hello everyone. Today we are going to move chapter 6 operators in C. In here we are going to talk about data types and the categories of operators in C language. First, data types. It means types of data. In computer programs we need to use different types of data elements. For example, numbers, characters, numbers with decimal points, and etc. To use different types of data in programs, computer programming languages must support for different types of data. The C language also supports for different types of data. Basically, there are 4 data types: int, char, float, and double. Int data type is for represent the integer values. Integers are whole numbers that can have both 0, positive and negative values, but no decimal values. For example, 0, -5, 10, 20 and so on. The size of int is usually 4 bytes. It means it is taking 32 bits from the computer memory. Then the keyword char is used to represent the single character. It means character type variables. The size of the character variable is 1 byte. Float is to represent floating point numbers and double is to represent double precision floating point numbers. Both are used to hold real numbers. Then what is the difference between float and double? The size of float or otherwise single precision float data type is 4 bytes. And the size of double or otherwise double precision float data type is 8 bytes. Different data types also have different ranges up to which they can store numbers. These ranges may vary from compiler to compiler. So in here I am not going to give you the ranges according to the data types. We will code and discuss that on the practical sessions. Then format specifiers. Format specifiers are defining the type of data to be printed on standard output. For example, if you want to pass the value of 5 into a print statement, you have to give it as percentage mark with D. So then it will print 5. For every int, you have to give the format specifier as percentage mark with D. So in the slide, you can see few format specifiers that we are using in the C codings. Percentage mark C for character types, percentage mark D for signed integers, percentage mark F for floating point data types, percentage mark LD for long signed integers, percentage mark LU for long unsigned integers, and percentage mark LLU for long unsigned integers. There are other format specifiers for other different data types in C. These are only few for your knowledge. That signed, unsigned, long signed, long unsigned, long unsigned. In here all are different kind of integers. We will discuss about those in after next couple of slides. Now just get the idea and the notations of the format specifiers in here. Now variable declaration and initialization. Declaration is to declare the type of the variable, the data type of the variable. It is not to declare the value to the variable. In here we are going to assign value 5 to variable A. Before assigning values, every time we want to give the data type of the variable first to the program. After giving the variable type only we can assign the value to that. So in here 5 is an integer, so int A, that is the declaration of the variable A. Then the assignment is simply the storing of value to a variable. Initialization is the assignment of value to a variable at the time of declaration. So in here a is equal 5, that is the initialization. We have declared the a first, now we are assigning 5 to a. So that is the initialization. There is another way to do this. The declaration and the initialization both in the same line. Int a equal 5. That is also same as the above. You can use any of these two as you prefer in your programming. Now we will see an example. Think you want to print 5 on your screen using C language. So first you have to declare a variable. So in here I have declared a variable I using int data type. Then the initialization I is equal 5. Now we want to print 5. For that we have to use the printf statement. In here, inside the brackets, inside the double quotes, %d /n, and after that comma I. Here %d for get the value in I, to print the value I value. In here I value will pass to the %d and print. After the comma, we have to give the value that we want to print, and /n for move the cursor into the next line. So this will print value 5. Now we will see another example. In here I have declared and initialized the variables first. I have done both declaration and the initialization in the same line here. First, int I equal 5. 5 is an integer, so data type is int. So now I value is 5. Then second, char C equal A. Remember that in C programming you have to give semicolon in end of every line. And this is only the body of the code, the main function I have given in here. To run this code you have to include libraries, main functions and those things. This is only the function body. Char is character data type because A is single character. So I have assigned it to the variable C, char C equal A. Then float F equal 7.2432. This number is floating point number, real number. So float is the data type. Then double also same, real number, double D equal 10.314. 10.314 has assigned to double variable D. So for printing, I is an integer, so we have to use %d. Then C is a character data type. To print character, %c. Then F is a floating point number, so we have to use format specifier as %f. But in here you can see I have given as the %.1f. It means I want only one decimal place. So you can see output as 7.2, one decimal place. And same the last one, D double variable, and I have given the format specifier as %.3f because I want the output with 3 decimal places. So you can see the output 10.314. If you want 2 decimal places to print, you have to give %.2f like that. So I think you have an idea about variable declaration, initialization and how to get the output using format specifiers. So I have mentioned 4 main data types earlier: int, char, float and double. The C language has something called type qualifiers which you can apply to those basic data types to get some more types. It can be used to change the original data type in sizes. Mainly there are two types of qualifiers. First one is size qualifiers. It includes short and long. And the second one is sign qualifiers. It includes signed and unsigned. The reason behind providing these qualifiers is that programmer can precisely choose a range of numbers suitable for the program whenever possible, which makes the program even more efficient. As an example, an integer variable can be defined as short int, long int or unsigned int. Here I have assigned the value 5 for short int variable s and very large value for long int variable I. For printing those two, there is format specifiers for short int %hi and for long int %ld. So it has given the output correctly. The word int is optional for long and short values. We can just say short and long. It means you can see in the slide, earlier we use short int and long int, but in here just short and long, but it will give the same answer as the earlier. Format specifiers also same, just only ignore the word int. When short qualifier is used, the range of a type is reduced, and on the other hand, use of long qualifier increases the range of the type. Int type can use both qualifiers. Double can only use long, and those long and short cannot be used with char and float data types. Considering integers, short is 16 bits and long is 32 bits. It means short is 2 bytes and long is 4 bytes. Therefore, integer is either can be 16 bits or 32 bits. And earlier also I have mentioned that the size of these types may be vary from compiler to compiler according to the computer's hardware. So it cannot be tell exactly this is the range. It can be different machine to machine. Then the signed and unsigned qualifiers. When the unsigned qualifier is used, the number is always positive or 0. And when signed is used, number may be positive or negative. If the qualifier is not mentioned, then signed qualifier is assumed. The unsigned qualifier is commonly used when we know in advance that the number is always be positive. The range of values of signed data type is always less than the range of values of an unsigned data type. Further, these qualifiers can only be used with int and char data types. You can see in the slide, unsigned int I equal 10. 10 is a positive number. Then signed int I equal 10. This is equal to int I equal 10. Both are indicating the same. And there is an important point. For signed int, the leftmost bit is used to represent the sign, the positive or negative thing. If the leftmost bit is 0, then the value is positive. If it is 1, then the value is negative. For example, you can see in here, we can write 7 in binary as 1, 1, 1. For indicating the positive, we have to write 0 before the 1, 1, 1. So 0, 1, 1, 1, that indicates the positive 7. Like that, for negative 7, 1, 1, 1, 1. The first one is indicating the negative sign. The plain int is signed. For example, int I equal 10. This is signed and value is 10. So now you have a clear idea about data types in C. Now we will move to the operators in C. What is an operator? Operators are used to perform some kind of computation or action when applied to variables or other elements in an expression. For example, you can see an equation on the slide that calculates the tax. City tax equal tax rate multiplied by gross income. In here, multiple sign and equal signs are operators. Multiple sign for multiplication and equal sign for assignment. In the second equation, sum equal a plus b minus c. In here, plus, minus and equal sign are operators. In programming point of view, an operator is a symbol that tells the compiler to perform an specific mathematical or logical functions. Operands. An operand is a data item where the operators act on. For example, you can see in the slide, if we consider the expression a plus b, a and b are operands and plus sign is the operator in here. Some operators require two operands. An operator which requires two operands is called as a binary operator. For example, a multiplied by b. In here, a and b are two operands. Some operators are acting on the one operand. An operator which requires only one operand is called as a unary operator. For example, I++, increment operator. Here I is the only operand. C language is rich in built-in operators. All these operators can be categorized into several categories. Those are arithmetic operators, unary operators, relational operators, logical operators, assignment operators, and finally conditional operator. Now we will go through one by one of these. The first category is arithmetic operators. Arithmetic operators are used to perform arithmetic operations in C programs. For example, 5 multiplied by 3, 10 plus 2. In here, multiple sign and plus sign are arithmetic operators. There are 5 arithmetic operators in C language. First one is plus mark, addition operator. We choose to get the summation, or otherwise we can say addition. Then minus, subtraction operator for subtraction. Asterisk, multiplication operator for multiplication. Forward slash, division operator for perform division. And finally, percentage mark, modulus operator for get the remainder after integer division. In arithmetic operations, operands are taken as numeric values. It means operands can be integers, floating point numbers, or characters. If you can remember, character constants represent integer values as determined by the computer's character set. So we can perform arithmetic operations on characters also. For example, int I equal 5 plus 3. In here, 5 and 3 both integers. After getting the summation as 8, it also assigned to the integer data type. The remainder operator requires both operands be integers and the second operand to be non-zero. For example, 5 can modulate by 2 or 3 or 4, any value except 0. Similarly, the division operator requires non-zero second operand. It means divisor must be a non-zero value. In the slide, you can see an example block of code. The variables are declared and initialized as int I equal 10 and int j equal 3. So both are integer values and integer data type variables. So for the printing purpose, the format specifier must be %d. Then the first one is I plus j. It means 10 plus 3, 13. That's okay. Then second one I minus j. It means 10 minus 3, 7. That is also okay. Then I multiply by j. 10 multiplied by 3, 30, that's also okay. Then I divide by j, 10 divided by 3. The answer must be 3.34. But you can see the output is 3. Why is that? Dividing an integer by another integer must be an integer. It is called integer division. So the fraction part 0.34 is ignoring here. Therefore 10 divided by 3 equals 3. Then the last one is modulus. 10 modulus by 3, 10 divided by 3, then the remainder is 1. So I modulus j, 10 modulus 3 is 1. In previous slide we talked about integer division clearly. So in here, in the division operation, if both operands or one operand is a floating point value, the result also must be a floating point value. As you can see in the example, int I equal 10, float j equal 3.0, I divide by j, 10 divided by 3.0, so the answer is 3.33333. J is a float value, so the answer also a float value. Here there are 6 decimal places because in here the format specifier we didn't give any number of decimal places that we want. So it is giving the default number of decimal places in here. Now in the second table you can see both variables I and j are float values. Float I equal 12.5 and float j equal 2.0. I plus j 12.5 plus 2.0 14.50 and I minus j equal 10.50. I multiple by j 25.00. I divide by j equal 6.25. Here we got all the answers with 2 decimal places because I have given the format specifier as percentage mark dot 2f. When we are doing arithmetic operations with character type variables, those characters will be converted to their ASCII values first. After that only the arithmetic operation is performing. You can see an example in the slide. There are 2 character type variables C1 and C2. Capital P has assigned to C1 and capital T has assigned to C2. So in first I have print the ASCII value for capital P by just passing the value C1 equal 80. Then C2 equal 84. Those are ASCII values for capital P and capital T. Then when we get summation C1 plus C2, it is getting the summation of 2 corresponding ASCII values as 164. And at last I have get the summation of C1 and C2 and 5. We can add 5 in here because ASCII value is also integer values. So the answer is 169. Then the second type is unary operators. Operators act on a single operand is called as unary operators. The common unary operators using in C are unary minus operator, increment operator, decrement operator, size of operator and cast operator. Now we see those one by one in descriptively. The first one is unary minus operator. This is used to denote minus values. For example, you can see int I equal minus 743. This operator is different from the subtraction operator because subtraction operator requires 2 operands, but this minus requires only 1 operand. You can see an example for subtraction in here, int I equal 5 minus 2. So if this minus mark using with 2 operands is calling as subtraction operator, and if it is using with 1 operand like the above example, it is calling as unary minus operator. Then the increment operator. The increment operator double plus marks is used to increment its operand by 1. In the example you can see int I equal 5. Then I have passed the value increment operator I for printf. So initially I is equal to 5, now I is equal to 6. So it will give the output as 6. And also in the second table you can see int I equal 5, then I equal I plus 1. It is equivalent to increment operator I, so it is also print the value as 6. So increment operator I and I plus 1 both are same. Then the decrement operator. This is the opposite of increment operator. This is used to decrement its operand by 1. In example you can see int I equal 5 and I have passed the value of decrement operator I for the printf. So initially I is equal to 5, now 5 minus 1 I is equal to 4. So it will give the output as 4. And also in the second table you can see int I equal to 5, then I equal I minus 1. It means it is equivalent to decrement operator I, so it is also print the value 4. So decrement operator I and I minus 1 both are same. Okay, now you know what is increment operator and what is decrement operator. These both operators can be used in two ways. We can use those operators before the operand and after the operand. First we will see that the operator which writes before the operand. Increment operator I. This is called as pre-increment. In here value will be incremented by 1 before utilizing it. In here you can see the same example we have discussed in the increment operator. Before printing I, its value will be incremented by 1. Then decrement operator I, this is called as pre-decrement. In here value is decremented by 1 before utilizing it. In here also the same example that we have discussed in decrement operator. Before printing I, its value will be decremented by 1. Then the second way is the operator can be written after the operand. I increment operator, this is called as post increment. In here value will be incremented by 1 after utilizing it. You can see the example. First it is printing the value I, after that only the printing I value will be incremented by 1. So it will be print 5, after that it becomes 6. After printing it is adding. Then I decrement operator, this is called as post decrement. In here also the value will be decremented by 1 after utilizing it. You can see in the example, first it is printing the value I as 5. After that only the printed I value is decrementing by 1. So it will print 5 and after that it becomes 4. After printing it, it will be decrease. Here you can see a clear example. First I have declared and initialized the integer variable I as 5. So in the first printf statement it will print the value 5 because still it is in the original state. So in the next printf statement I increment operator, the post increment. So it will print first and then increase. So it will print 5 and now the new I value is 6. Then again when we are printing just I value, it will print 6. Then the I decrement operator, post decrement. So it will print first and then decrease. 6 will be print and new I value is 5. So again just I, then 5, the decremented value. Don't confuse with the pre and post decrements and increments. Just simply clearly get the idea into your head. The next unary operator that we are going to discuss is size of operator. Size of operator returns the size of the operand in bytes. The size of operator always precedes its operand. The operand may be an expression or it may be a cast. So in the example, I have declared three variables, int I, float f and double d. Then for getting the size of those, I have written printf statements for each of them, and I have used the format specifier as %lu for long unsigned integers. The sizes must be positive, that's why I have used long unsigned integers. If you want, you can use a %b for just for the integers. It doesn't matter. So the outputs came as integer size as 4 bytes, float size as 4 bytes and double precision size as 8 bytes. Like that, we can use size of operator to get the number of bytes allocated in the various types of data items. The last unary operator that we are going to discuss is the cast operator. In general terms, a reference to the cast operator is written as type within the parenthesis. C allows the programmer to convert the type of an expression using the cast operator. This is done by placing the desired type in parenthesis before the expression. The operation is called as typecast. For example, look at the table. I have divided 5 by 2 and I want to put it as the double variable. 5 and 2 both are integers, so it will give the answer as the integer. It will give 5 divided by 2 equal to, but I want the fraction part also, so I have given double inside of the parenthesis before the 5. Then 5 will convert to the double value and divide by 2. So it has given me the double value answer as 2.5. In the second example, I have divided two double values 3.5 by 2.1. So the answer also will be in the double format. I want the output in the integer format. So I have given the cast to int before the expression, and also I have put the parenthesis to the expression. So first the expression is evaluated and get the answer in double. After that it will cast into int. That happens because I bracketed the expression. Earlier in the above example, double is only valid for variable 5. 5 is only cast into double. After that the expression is evaluating. Those both are different. Now we will move to the relational operators. Relational operators are used to form logical expressions. For example, you can see I is less than j, k is greater than 3, n is equal to 5, like that. These expressions represent conditions that are true or false. The relational operators that we are using in C are less than or equal to, greater than or equal to, and not equal to. In C language, true is represented by 1 and false is represented by 0. So the results of a logical expression is either 1 or 0. For example, suppose that I, j and k are integers and their values are 1, 2 and 3 respectively. So look at the table. I is less than j, it means 1 is less than 2, it is true. So in C it will be 1. Then next, in here we have to first evaluate the inside of the parenthesis. I think you can remember the order of precedence in the operators. I recalled that in the first or second lecture. So I plus j, it means 1 plus 2 equal 3 and k is equal to 3. So both are equal, then true. So the C interpretation is 1. The third one is k. It is not equal to 3 but k is equal to 3. So false, then 0. Fourth one is I is equal to 1. That is true. So the C representation is 1. So in here you can see the program for previous slide example. same equations, and I have given the output within the white border box. This is the way to program relational operators in C. And here there is another important thing. Until now we have written the main function with int main and return 0. But in here you can see I have started with the void main and there is no return type. This is another way to write a function, no return type. If we are giving void in the function heading, we don't want to give the return statement. We are not returning anything. If we don't want to provide the result value to the function caller, we can use void method for it. The next type of operators are logical operators. C language has two logical operators, logical and logical OR. Logical AND represented by double ampersands and logical OR is represented by double vertical bars. Logical operators are used to combine logical expressions. The operands are logical expressions in here. The results of a logical AND operation will be true only if both operands are true, whereas the results of a logical OR operation will be true if either operand is true or if both operands are true. In the other words, the results of a logical OR operation will be false if only both operands are false. I think you all know about how to get results in the logical AND and OR. Now consider the example in the slide. I is equal 5 and f is equal 7.5. So in first expression I is less than 6, so it is false, and f is greater than 7, so it is true. False and true indicates the results as false. Same as the relational operators, here also we are using 0 and 1 for C language interpretation. So the answer is 0. Then the second one, I is greater than 4, that is true, or f is not equal to 7.5, that is false. So true or false, then the answer is false, so it can be represented as 1. Then the last one is I is greater than 3, that is true, and f is less than 10, that is also true. So true and true, the answer is true and it can be represented as 1. And this is the code for previous slide logical operators example. This is very simple, you can use operators easily in your programming. In here also I have used the void returning, and I have given the output in the right side of the code. You can easily see and understand the code and get the output. Next we will move to the assignment operators. Assignment operators are used to form assignment expressions. Assignment expressions assign a value of an expression to an identifier. I have mentioned earlier also, identifier can be a name which represent a variable, constant or etc. The most common assignment operator is equal sign. The format of using assignment operator is identifier equal expression. The expression value will be assigned to identifier, or else the right side value will be assigned to left side. So the identifier represents a variable while the expression represents a constant. You can see some examples in here. First one, assign integer value 5 to variable I. So the data type must be int I equal 5. 5 will be assigned to the integer variable I. Then the second one, there is an expression in the right side. The results of the 3.14 multiplied by 4 multiplied by 4 will assign to the float data type variable A in here. This 3.14 value is a float value, so the results also will be a float value. So we have to assign that value to a float variable. And there are more examples in here. Float delta equals 0.001. So the value 0.001 will assign to float variable delta. After that, float f equal delta. From the above one, now delta is 0.001. So this delta value will be assigned to a variable f. So now the float variable is f value is 0.001. Then next, int sum equal a plus b. Here a and b must be integers because we are going to assign the results of a and b into an integer variable sum. After calculating a plus b, we can assign that to the variable sum. In the slide, you can see an example program for assignment operators. First, I have declared and initialized the variables int I equal 5, float delta equal 0.001, float f equal delta, float a equal 3.14 multiplied by 4 multiplied by 4. So first I want to print I. The I value is directly I have given I equal 5. Then it will print I equal 5. Then I want to print delta. In delta value also given as a float value 0.001. So it will also print as delta equal 0.001. Then I want to print f. In here f is equal to delta. Then the delta value will assign to f. So f will print as f equals 0.001. Finally the area. In area I have passed the value a. The a value can be given by 3.14 multiplied by 4 multiplied by 4. The result is 50.240. So it will assign to area and print. In here, for every float value, I have given the format specifier as 0.3f. So it will give 3 decimal values. You can see the output in the right side of the slide. Finally, every identifier has assigned by a constant. Next, we will talk about automatic type conversion. Automatic type conversion means when two operands in an assignment expression which are in different data types, then the value of the expression on the right side will automatically convert it to the type of the identifier in the left side. Simply the left side type will apply to the right side if both sides data types are different. For example, if int a equal 8.7, so the left side is int and the right side is float. So in this case 8.7 will be converted to 8 as we are assigning a float value to the integer. Then next see, suppose that I is an integer type variable. So in here first one I is equal 3.3. 3.3 is a float value and I is integer, so it will convert it as 3. And the second one 3.9, it is also float value and I is integer value, so it also converted as 3. It doesn't matter that decimal value is 3 or 9, all are converted to int. So the third one is I is equal minus 3.9. Here also 3.9 converted to minus 3. All the right side values have been converted to int. So a floating point value may be truncated if it is assigned to an integer identifier. Now suppose that I and j are both integer type variables and j is equal to 5. So in the first expression I is equal to j. I and j both are integer values. So the j value will assign to I value. So 5 will assign to I. Then I is equal 5. Then the second one I is equal j divided by 2. J is 5 integer value divided by 2. Then it give the integer value result 2. It can be assigned to I value. So I is equal to 2. Then the third one is I is equal to 2 multiplied by j divided by 2. In here we have to solve left to right. So first 2 multiplied by j, then 2 to the 2 multiplied by 5, 10. 10 divided by 2, 5. It is integer value. It can be applied to I. So I is equal 5. Then the last one, I is equal to multiplied by inside of the parenthesis j divided by 2. So first we have to do j divided by 2. So j is 5, then divided by 2, both are integers, then 2 is the value. So 2 multiplied by 2, then 4, that is also integer value. So that can also give to the assign to the I. So the I value is 4. Now look this example. Assume that I is an integer type variable, and we will see how it is working with the character type variables. In here, first one is I equal x. I is an integer type and x is a character type. So the ASCII value of the character x 120 will assign to I. So the int value I equal 120. Then the second one, I is equal to 0. In here 0 also a character type. So the ASCII value for 0 is 48. So 48 can assign to I value. So I is equal to 48. Then the third one, I is equal to x minus 0 divided by 3. So 120 minus 48, 72 divided by 3, 24. So 24 can assign to I. Then I is equal 24. Then the last one, y minus 0, it means 121 minus 48, 73 divided by 3, 24. It can also assign to integer value I. So I is equal 24. So the value of the character constant assigned to a numeric type identifier will be dependent upon particular character set in use. From the above 3 examples that I have discussed, we can get the idea that how automatic type conversion is happening. The careless use of type conversions is a frequent source of error among being programmers. So careful. Then the multiple assignments. We can assign a value to a multiple variable at once. This is called as multiple assignment. You can see the syntax in the slide. Identifier 1 equal identifier 2 and so on equal to expression. And there is an example in the slide. Int I, int j, I equal j equal 5. In here 5 will be assigned to both I and j. In this case, assignments are carried out from right to left. You can see an example for multiple assignments in here. In here, first I have declared two variables, int I1 and int I2. Then I have assigned values to those. I1 equal I2 equal 5. Then 5 will assign to I1 and I2. Then float F1, float F2. Two float values I have declared. Then I have assigned the value 10.25 to F2 and F1. So F1 equal F2 equal 10.25. Then the char value I have declared char C1 comma C2 equal A. So in here A will assign to only C2, not to C1. The char data type is applied to C1 and C2 both, but A is assigning to C2. So you can see in the printf functions, I1 will print as 5, F2 will print as 10.25, but C1 is not printing, but C2 is printing as A. Next, additional assignment operators. C contains another 5 additional assignment operators in addition to the simple assignment operator. Add an assignment operator, subtract an assignment operator, multiply an assignment operator, divide an assignment operator, and module an assignment operator. If we consider the add an assignment operator, it is in the form expression 1 plus or equal expression 2. This means expression 1 equal expression 1 plus expression 2. it adds the right operand to the left operand and assign the result to the left operand. Then subtract an assignment operator. It is in the form expression 1 minus equal expression 2. This also can be written as expression 1 equal expression 1 minus expression 2. It subtracts the right operand from the left operand and assign it to the left operand. The other three assignment operators are also in this format. Now consider the example for the assignment operators. Suppose that I and j are integer variables and their values are 5 and 7. So in the first expression, int j add and assign 3. It means int j equal j plus 3, then 7 plus 3, 10. Then the second one is j minus and assign 3, then it means int j equal j minus 3, then 7 minus 3, 4. Then the third one is I multiple and assign 5, then it means I equal I multiple by 5, then 5 multiple by 5, 25. Then the fourth one is I divide and assign 2, it means int I equal I divide by 2, so the I is 5, 5 is an integer, 5 divided by 2, it means 2 integer value, so it can assign to I, the final value is 2. Then the last one is I modulo and assign 3, it means I equal I module 3, I is 5, 5 module 3, then the remainder is 2, it is also integer value. Like that we can use additional assignment operators in the C codings. Now I think you have a more clear idea about the assignment operators. Then the finally last type of operator is conditional operator. The conditional operator is in the form of question mark and colon. An expression which uses a conditional operator is called as conditional expression. We can write it as the form of expression 1 question mark expression 2 colon expression 3. When evaluating this expression, expression 1 is evaluated first. If the expression 1 is true, then the expression 2 is evaluated and then the value of expression 2 becomes the value of the conditional expression. If the expression 1 is false, expression 3 is evaluated and the value of the expression 3 becomes the value of the conditional expression. From the example you can clearly see the above. The expression I is less than 0 is evaluated first. If it is true, the entire conditional expression takes on the value 0. Otherwise, the entire conditional expression takes on the value 100. And note that conditional operators can be nested. It means more than one conditional operators can be built using one conditional operator. The conditional operator acts on 3 operands. An operator which acts on 3 operands is called as ternary operator. You can see in the example C equal inside of the parenthesis A is greater than B. If A is greater than B, A, otherwise B. In here A is greater than B is a one operand and A is another operand and B is another operand. So there is 3 operands. And there is another example in the table. I have declared and initialized 2 variables first, int I equal 5, double D equals 7.4. So after that I have written a print statement and I have given the conditional operator inside of the print statement. In the first one, if I is less than 10, then it have to print I, otherwise 0. In here I is 5 and 5 is less than 10, so it have to print I is 5. In the second one, I is greater than, if I is greater than D, so it have to print I, otherwise 0. In here I is 5 and D is 7.4, so it is false, so it have to print 0. So it is printing 0. I think you have clearly got the idea about conditional operators. Okay, today you have got an idea about the data types which are using in C and the details about the categories of operators that we are using in C language. You can go through the reference books and find more details about those things. And I have uploaded a simple worksheet, a PDF version of these slides, and a PDF of a C operator precedence table. Find those. If you have any doubt, you can contact me through the email. I have given that as the usual in the first slide. Thank you.